All right, welcome back to Mr. P Helps with Algebra 2. This is Unit 1, Topic 2, SLT number 6. Graphing radical functions, expressing symbolically, and showing key features of the graph, like increasing, decreasing intervals, domains, and ranges. Okay, so warm up. Given a function f of x, find its inverse g of x. In this case, we've got multiplication and then addition. If you use the order of operations, which is parentheses, exponents, multiply, divide, add, and subtract, has to be done in that order. I'm going to list out the order here. So this is times 2 would have to be first. If I knew the value of x, and I was substituting that value in for x, I would have to multiply first and then add second. Now, when you're finding the inverse, you're going to do the exact same operations, but the opposite operation in the opposite order. So instead of adding 5, I'm going to subtract 5 first, and then instead of multiplying by 2, I'm going to divide by 2 second. Okay, so g of x is equal to our variable minus 5, and then divide everything by 2. So there's your answer. All right, over here we've got times a half first, and then subtract 3 second, using the order of operations. So the inverse relation, relation would be plus 3 first, and then divide by a half. Now, dividing by a half is actually the same thing as multiplying by 2, or 2 over 1, because of, you could leave change whenever you're dividing by a fraction. You could leave the first number alone, change to multiplication, change this to its reciprocal, which is 2. All right, so building it there. So g of x over here is equal to a number plus 3, and then multiply everything by 2. All right, so getting into this lesson, so we're going to be looking at quadratics. So when you're translating quadratics, the h in this case, this is called vertex form. A does two things, which I'll talk about last. H translates the vertex, either left or right, and it's the opposite of what you would normally think. So if it's minus a positive number, it actually goes to the right. If it's plus a negative number, if it's plus a positive number, then it actually goes to the left. So once again, so if you see subtraction, it goes right. If you see addition, it goes left. The k makes it go up or down. So if it's positive, it goes up. If it's negative, it goes down. And then the a does two things. So it does a reflection. If a is a negative, it's going to take that parabola and it's going to turn it upside down. It's going to reflect it over the x-axis. Or if it's got a number that has an absolute value greater than 1, then it's going to make it narrower. So it's going to it's called the dilation. So it's going to dilate narrow. The bigger the a, bigger the number, the more narrow it gets. Now the way a is basically it tells you how high the next number is. So if it's 3, that means the next number is 1, 2, 3 up, which means it has to be pretty narrow to go up that fast. And if it's a fraction, that means, well, for every one right, it's only going up a little bit, like this one is. This one's not. This one's just a little bit wide. It's not right here. So I would think normal is going up 1 for every right one, but this is actually going up about a half for every right one. All right, so same rules as before. I'm just going to show this, everything I just said just a second ago. You can stop the video if you need to read that. Same notes right here, just some examples. So this is translating up 2, this is translating right 3, and this is reflecting over the x. Remember we said if a is negative, it makes it go upside down, and if it's a fraction, it's going to make it wider. So that's the dilation factor. All right, so there's a lot of notes there. So getting to the first question, this is called the parent function. That means this is the function that's it's the most basic quadratic function you can possibly make. Graph f of x if it's x squared. So that means if x was 0, y would be 0. X 0 squared is 0. 1 squared is 1. 2 squared is 4. Now, same thing goes for the negatives. Negative 1 is also times itself as 1. Negative 2 times itself is also 4. So this is the parent function of a quadratic. Right, so determine the domain and the range. The domain will be all real numbers because it's going left and right infinitely. And it's got a range that would be anything greater than or equal to 0, because the lowest it possibly goes is 0, and it goes infinitely up. I'm going to talk a lot more about that. There's a lot of pages to go, so I'm just going to keep it moving. If we restrict the domain, so if we want to do the inverse, is the inverse a function? So let me get to this question, because if I was to do the inverse of all of these points, 0, 0 stays 0, 0, 1, 1 stays 1, 1. I'm just switching them. Negative 1, 1 becomes 1, negative 1. Basically, you're going to end up with a graph that looks like this, which you're probably thinking that purple one is not a function. And that's right, because this side is the inverse of this side. But this side is the inverse of this side. Now, the opposite of squared, if this is x squared, this would be the square root of x, because that's the inverse of x squared. So what you have to do is you have to limit the domain to the purple side. So you always want to limit the domain to the positive side of the domain, because this negative side is going to be, the inverse is going to be negative down here. And the reason why that doesn't make any sense is because you can't do a square root of a negative number, because there's no number that times itself would give you -9. It's not, there's no real number at least. So we have to limit our domain to the positive side so that we're left with an inverse that does make sense, because this side's inverse would not make any sense in the context of this question. All right, so on the same graph, so write the equation at inverse. Okay, so the inverse function, I think I've actually already showed you. It's going to look something like that. Just look back at the one I just made a second ago. On the same graph the relation inverse. Okay, so x squared plus 3. So now we got a translation. If you remember the notes I said earlier, this is not inside the parentheses. So this is not left or right. This is actually up or down. This is going to be up. 1, 2, 3. Now from there, I can just test every other number, because I know 0, 3 was going to be the vertex. So if I put 1 in for x and solved, 1 squared is 1. 1 plus 3 makes 4. 1, 4. 2 squared is 4. 4 plus 3 makes 7. And so forth. And now the other side is going to be an exact mirror image, like such. All right, so would the inverse of this be a function? No, it's not again, because the inverse is going to look something like this. Okay, I know that was poorly drawn, but I think you get the idea. It's going to be at 3, 0, and it's going to look the exact same shape. But it's not a function, because if I do a vertical line test, I can draw a line that hits the same graph twice, which means that domain has 2 different ranges. That's not a function. So once again, you would have to limit the domain to ensure that its inverse is a function. All right, so this is kind of like I just talked about. This is the exact same thing. This is not up 3. This is actually left 3. 1, 2, 3. Because remember, whatever's on the inside is always the opposite of what you would think. So this is not right. This is actually to the left. And then it's going to look just the same like this. Now I'm saving some time because I know I got a lot of pages to get to. X squared I'd already done earlier in the video. So let's take a look at this one. So how is this being translated? I see 1 to the right, and I see up 3. So right 1, up 3. There's my vertex. That's the point of vertex form. Now this minus sign down here is actually a negative sign. That means the A is negative. That means that this is being reflected over the X, which means it's actually facing down. And since there's no number there, we assume that anything times 1 is itself. So anytime there's no number, you just assume it's 1, because anything times 1 is itself, the identity property. And so that means the next number is 1 down. You can do the same thing on the other side as well. Now you can't just keep going 1 down, 1 down, 1 down, 1 down. A only tells you the distance to the next point. So if I want to find the next one after that, I'm going to have to test it. 1, 2, 3, or using graphic calculator. 3 minus 1 is 2. 2 squared is 4. Times the -1 makes -4. Plus 3 makes -1. F of 3 is -1. We know this side's going to be exactly the same. I've got my 5 points, which is the bare minimum that I need in order to make a graph. So the vertex we already said was at 1, 3, because it's right there, 1, 3. The domain would be all real numbers, because this is going infinitely both left and right. The range would be y is less than or equal to the highest point. So the height of this function is below 1, 2, 3. So it looks like less than or equal to 3. Increasing interval. So whenever you're doing increasing and decreasing intervals, that means when. When was the function increasing and when was it decreasing? This is tough because you got to forget about the arrows. The arrows just tell you that it's going endless. That does not mean that that's the direction that it's going. You always look at a function from left to right. So if I go left to right, when was my pen going up and when was it going down? It was going up on this side of the vertex. So whenever the x is less than 1, it's increasing. And whenever the domain is greater than 1, it's decreasing. Now, when it's at the vertex, I don't consider it increasing or decreasing. It's just a solid point. It has to be either before it or after it before it's actually doing something. Identify the restriction of the domain, so this ensures that this function is inverse is also a function. So you could either limit this side or this side, because like I said before, I always limit the domain to the positive side. So that would be this side. So when x is greater than or equal to 1. All right. So square roots. So this can get a little bit tricky because we got to figure out what numbers would make this make sense. So only certain numbers have square roots that are not irrational. Like 0 is the lowest number that you can do a square root of that's not irrational. Irrational meaning it's a number that ends, that terminates. So 1 is a perfect square. 4 is, 9 is, 16 is, 25 is. Hopefully you see the pattern. 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4. Square root of 0 is 0. Square root of 1 is 1. 1 times 1 is 1. 2 times 2. 3 times 3. 4 times 4. All right, so then I just go ahead and graph. 0, 0, 1, 1, 4, 2. And what you're going to end up with is a graph that looks like this. It has an endpoint at 0, 0. This is the parent function of square roots. Domain would be x is greater than 0. Range is y is greater than 0 because everything's above 0. Increasing interval will be x is greater than 0 the whole time, and it never decreases. Never. Now, when you have a question like this, you got to be a little bit more strategic because you want the inside the radical to be these same numbers, 0, 1, 4, 9, and 16. But you can't just make x those numbers. You can't make x 0 because 0 plus 5 is 5, and the square root of 5 is an irrational number. So we got to be sneaky about this. So we got to think about what would x have to be to make the inside of the radical 0. And it would have to be negative 5. Negative 5 plus 5 is 0. Square root of 0 is 0. What would I have to make the inside to make it 1? And that would be negative 4. That gives you 1. Negative 4 plus 5 is 1. Square root of 1 is 1. 4. What I have to do to make it 4? It would have to be negative 1, and that would give me an answer of 2. To make it 9, it would have to be 4, which gives me an answer of 3. And then I can graph those points. Negative 5, 0, negative 4, 1, negative 1, 2, and so forth. Now, you'll notice that basically it just got translated 5 to the left. Just like a quadratic, these follow under the same rules. Whatever's on the inside of the radical moves it left or right. And if there's something on the outside of the radical, that means it's going to move it up or down. All right, so I'm just going to talk transformations so I don't have time to answer all these questions or do the t-tables. This is a transformation that's going 1 right and 2 up. So 1 right, 2 up. I know that's going to be the endpoint. And then from there, I could just test it by putting 2 in. 2 minus 1 is 1. Square root of 1 is 1. 1 plus 2 is 3. So 1, 3. And then I'll advise you just to use a calculator for the rest. For this one, now we've got a negative sign on the outside. I haven't talked about that, what that does. So that is actually going to make it go in reverse. It's going to make it go backwards. So in this case, I can use any numbers I want for x. So that could be 0, 1, 4, and 9, just like I want. 0 square root of 0 is 0. 0 times negative is still 0. Plus 7 is 7. Square root of 1 is 1. Times the negative is negative 1. Negative 1 plus 7 makes 6. Square root of 4 is 2, negative 2, and the 7 makes 5. Square root of 9 is 3, negative 3 becomes 4. All right, so 0, 7 is up here. 1, 6 is there. 4, 5 is there. Okay, so as you can clearly see, what's happening is it looks the same as this, only it's going negative. It's going down. It's decreasing in this case. All right, so the outside makes it decrease. And if the negative was on the x, it makes it go backwards. And I think I actually said it backwards earlier. So like this one is going to be going down. I know it's going to be going down because of that negative. This one is going to be going backwards because of that negative. All right, so this one is going to have a endpoint at negative 2, negative 1, which is something like right there. And it's going to be going up. It's going to be going up not as quickly. All right, homework. So x minus 2. So I know it's got a translation that's right over here. It's going to have its endpoints right there and there. I know I'm going a little bit fast because I'm running low on time. So let's see. If I test 4, 4 minus 2 is 2. 2 squared is 4. So 4 will be up there. So it's going to look like that and like that. Vertex at 2, 0. And the domain would be all real numbers. The range will be anything greater than 0. Increase interval is anything greater than 2. Decrease interval is anything less than 2. Restricting the domain would be anything greater than 2. This one, square root, so it's got a translation of right 1, 2, 3, and plus 2. Sorry, I got to do both.